Hey everybody, this is Larry. This is day 2 of the February Leetcode Day Challenge. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about today's problem. When it wants to load. Alright, there we go. Today we have a difficult problem, a hard problem on 3013, divide an array into subarrays with minimum cost 2. Alright. We did this yesterday, right? Kind of, maybe. I don't remember it already, though. Honestly, I don't know. I mean, I think it was an easy one, right? Something like that. So I don't remember it. So okay, let's read it then, because that's the best way to understand what the problem is asking. Hope everyone's doing okay. It's still very cold here in New York, so I'm like shivering a little bit. Last night, or not last night, but yesterday when I was doing the bi-weekly contest, we had that Q4 with the ridiculous divide and conquer optimization dynamic programming and the convex hull dynamic programming, and it took me 2 hours. The reason why I brought that up is because my feet were frozen at the end of it. So hopefully this one won't be as long, because I don't know, my where I'm filming this is just a little bit cold, and my bedroom isn't that much better, so I don't know. But let's go. All right, so you're given a zero index array of integers nums of length n and two positive integers k and distance, or dist. The cost of an array is the value of the first element. For example, that was just to pick the two smallest ones. Now I remember. For example, the cost is 1, 2, 3, 3, 4, 1. You need to divide nums into k disjoint contiguous subarrays, such that the difference between the starting index of the second subarray and the starting index of the kth subarray should be less than or equal to dist. In other words, if you divide nums into the subarrays, then why the second subarray? That's interesting. And the starting index is less than or equal to distance. Okay, I think I get it, but I think these are the things that so k, we're only given k, right? So that means that's the last element, right? So I think one thing that I always like to do, and I always like to say, sometimes I don't do it. I mean, well, I don't do it because I do it in my head, but I usually try to think of it that way. But this time, maybe it's worth kind of drawing it out a little bit. So let me pull up the drawing things real quick. My computer's a little bit slow, because, I don't know, who knows? Maybe I need to get a new something, or just a server or something. But okay, so basically, all I know is that, okay, so you have some array, and you're trying to do, and then the second here is the here, and this is the last division, if you will. And then basically the distance and they changed something with this app I'm using, because every time I change colors, half the time it doesn't work. This is less than distance or something, right? Or the other way around, right? So that's kind of the visualization that I think I'm seeing. Maybe off by 1 or something. Okay, so return the minimum possible sum of the cost of these subarrays. Is this supposed to be hard, or am I confused? Because, okay, so the reason why I said it like that, and I don't even think, I mean, I looked at n, but it doesn't really matter, because the idea that's in my head is n log n, so it would have been fast enough. Because the idea here then, right, and I thought I brought it up, but I actually didn't press the button, is that, and this is somewhat building off yesterday's, but it's not a hard thing to build off, but it just means that, okay, well, if this is the case, right, then that means that we're just taking, and maybe I'm off by 1, like k, instead of k is k minus 1 or something, because we cannot choose the first one, right? But if that's the case, then knowing what we know from yesterday, it just means that we already took 1, so it's going to be k minus 1 distributed here. You also cannot choose to, well, I mean, you can, but let's just say we're brute forcing the beginning, right? If we're brute forcing the left side of this, we can then consider it as I think my weird USB port just like freaked out. Okay, let me plug it back in again as I was doing. I don't know why computers are so tricky. Sometimes it connects, disconnect, and now my... Okay, there we go. If it wants to show up, that would be nice. Okay. So anyway, so you want to... I say brute force, but what I mean is in like a sliding window kind of way of, okay, test it for this one. My computer's lagging, so now it looks like an... Okay. You test for this one, then you move from left to right, and you test it for this one, right, the next index, and so forth. And of course, as you kind of go this with the distance, then this just becomes a sliding window, right? And then now, let's just say you have a sliding window, or you're playing with the idea of the sliding window. And then, but even before the sliding window, though, you just have a regular window that you haven't slid yet. And in that case, you just find the k minus 1 min elements, right? Or the sum of them, rather, right? The sum of the k minus 1 min elements, and then we're good. And then when we slide, we move elements, and then we add elements, right? And then you still keep track of the smallest whatever elements. And there are a couple of ways you can do it, but like you could use 2 heaps, you could use 1 heap with maps, and so forth. Yeah, I think that's basically the idea. I think the idea that I want to implement, if my computer wants to be not crappy, that'd be nice. Okay, but yeah, I'm going to use 2 sorted lists, so then we can keep the invariants a little bit easier, right? So ref n is equal to length of nums, and then now we just kind of brute forced that, I'm just writing it structurally, not necessarily, all the code from top to bottom. Especially since my computer is a little bit slow. Give me a second to see if I could kill anything obvious, like processing. I mean, all the obvious ones are like, I actually have quad code running somewhere. Sorry, friends. Computer stuff. But I don't even think that's it. That's just memory. I'm trying to find CPU. CPU. Well, it takes 45% doing nothing. Are you serious? Okay. Maybe this is a little better now. Anyway. Right. So this is now the start, right? So you can say start is the second index or whatever that they say, second partition, or is the index of the second partition, right? So we have to set it up a little bit first. Okay, actually, no. I mean, this is true, but we actually want to set up the end, right? So that we set up the start from the end, and then you move the start plus 1. Okay, right? So, I mean, sliding window stuff. Yeah. Maybe I'll just say left, right, so that's a little bit cleaner, because n seems like a little bit weird, right? So then now to define what's right, right is the index of the last partition, right? Or it's not the index, it's the last possible index of the last partition, right? Because it can be before that, it's just that this is the ring, right? So that means that we have to set it up a little bit. That means that we have to put in the first, so here we'll say, let's just say we have 2 sorted lists, right? Smallest and others, right? And here we just have to right? We have for I in range of, and this is just to kick it off, we start from 1 and then we go to k. Is it inclusive? Well, we want to go k plus 1. No, from 1 to k inclusive has k elements, right? I think that's the interpretation. Oh, no. It's not k, it's distance. Sorry, whoops. But, so to be, let me look at the formula. They have it somewhere, right? I thought I saw it somewhere. Oh yeah, there we go. So that, because it's less than or equal to, that means that there's distance plus 1 element. So yeah, right? I don't know. If we're off by 1, we'll just fix it. Right? Anyway, for each of these numbers, we want to say x is equal to num sub I, right? And then we add smallest, we add x. If length of smallest is greater than k, then we take the biggest number. Yeah, we take the biggest number. Oh well, we also have to add a total, which is the sum inside smallest. And then you also maybe want to just have best for the best answer, right? So infinity. Yeah, so then now, and this is, we're going to reuse this, so maybe we could write a helper, but I'm just lazy, it's fine. So if it's bigger than k, then we take out the biggest number, right? Remove biggest, and then we put it into others, right? We're gonna just run it real quick to make sure I don't have any weird indexing things. So I assume distance is okay, yeah. So I mean, we still have to look, but okay. So then now, best is just equal to total, because now we have to. Oh, I didn't add this. Well, no. Here we add x, and then if this is we subtract biggest, right? Yeah, and then now. This is to set up the window, the initial window, right? And then now we have to slide it. So then here on the right side, we actually start at dist plus 1, I think, maybe. Yeah, because that's the first one that's not being processed for this. So then now we have to first remove from. Which one do we remove? Well, I mean, also just to be clear, the order doesn't matter. You could add first or remove first. You know, it's just you have a sliding window. You want to move to, just add and remove, right? So we add. Yeah, let's just do the adding first, right? So we'll do this thing. Add of. Let's just say x is equal to num sub right. And also we can write left is equal to right minus distance. I think that's right. Maybe I'm off by 1. No, that's fine. I'm lazy to think. Yeah, we add, right? And then the same thing. This is where I said maybe I should, it's fine, right? Alright, fine. Maybe okay. Right. So maybe we will do a helper. That doesn't make sense that I'm not. I'm just being lazy for no reason. Right. Right? And then now we have to remove, right? How do we want to write remove? If x is in others, then we just understand remove x, and then we return. Otherwise, it's in smallest, so then smallest dot remove x total and then now we take the smallest number from others, so that should always be possible just by pigeonhole, right? I guess that actually makes it easier that we do add first, because then now we always are making sure that we have k plus 1 element at least. So, but yeah, well, actually, in that case, then we have to assert. Right, and then small. Well, I can write smallest again, but that just writes current is equal to smallest, the smallest number in the smallest, and then no, in others. Whoops, I keep on saying smallest. I got confused. Others dot remove current. Yeah. And then smallest dot add current, and we're good. right? So then add x, we move y, right, where y is equal to num sub left, and then yeah, and then best is equal to min, is it? Min of total, and we should be good, basically. Just a basic sliding window problem, assuming that, did I do something? Is my math wrong? The smallest should always be length k. So after we add, right? It's a little bit weird, but okay. Let's others. Print it out real quick. What was it before? Wait, the add doesn't. Do I reuse k by accident? Oh no, I mean, length for smallest is definitely greater than k. So why is that? Oh no, this is the second one. Okay. Did I confuse distance and k? I did confuse distance and k. Oh. Also, I forgot that k includes the first one, so we just need to, okay, yeah. I forgot that k includes the first index, so we have to subtract from 1, and then maybe best plus num sub 0, right? Okay. I mean, we would have caught it another way, but like, that's very hard to not do, but well, would I code against smallest than others? Okay, what are the variables? 3. So it's the 2 smallest. Distance is 1. Wait, how does that work? If k is 3, distance is 1. Does that? So okay, so you have choose 2 numbers with a distance of 1. Does that work? I guess so. Then why does this? Huh? I thought distance have to be bigger than k minus 2. So I'm just having an off by 1 thing in my head, I think. Because this is, well, so distance have to be greater than k. Right, so distance has to be greater than k minus 1. So I think my initial kickoff is just wrong, that's all. Because distance have to be bigger than k minus... Oh wait, I think I confused it the other way around. So that means that... no, distance plus 1 means the... Oh no, I'm looking at the wrong one. It's this one. But... that means that we look from index 1 and 2. No. This is distance of 1, so it looks at 1, 8, right? And then that's it? That's not right. I mean, this is where maybe I am off by 1. Yeah, maybe I'm just off by 1, because it should be from 1 to distance plus 1, inclusive, is the distance. So, okay. All right, but I have to fix this now then. Yeah. Okay, so now we're wrong. I mean, this is already just 5, so I think I'm just not doing the math right. Right? And that is right. I'm just struggling because of off by 1s. I think the idea is mostly right, but today I am not having a good day of off by 1s. But okay, distance of 3. So it's going to be these 3. You get... So you want to pick 2, distance of 3. This is index 1, 2, 3, 4. So distance of 3, we pick 2. This is going to be 2 and 3. Okay, right? And then what happens? I mean, did I miss an index? That doesn't seem likely. I mean, this is clearly an off by 1 because I'm removing the 2 and not the 3. Huh. No, okay, yeah, because this equal then less than distance thing is just confusing me a lot, because that means that if right is this one, then and the minus distance it's going to be equal less than, okay, so that means that this is this minus 1 because left is inclusive, so we want the one that we just moved. Yes, okay, fine. Okay, this is off by 1's are hard. You have to really like spend time to think about it, for me anyway. Let's get a quick spin. Yeah, looks okay. I mean, I use sorted list, but honestly there's nothing. Well, I mean, it is kind of trickier to do. I was gonna say you could use a heap or a priority queue, but it is a little bit tricky to remove stuff in the middle. You could use obviously a delayed one, but for this problem it is definitely a little bit tricky. But yeah, but that's it really. You just have to, you know, build on everything that we said. I'm gonna go show you the code real quick. This is because the first element, right? No choice here. We have 2 heaps. The sum inside the smallest, which is what we're tracking, and then everything just sliding window. We just have to keep track of the things, and then, you know, this is almost like the median finding thing really, but I don't know. And then yeah, set up the initial and then set up the whatever, and then we're good, we're Gucci. But yeah, this is gonna be n log n because everything is just log n, right, with a O of n loop. And did I miss anything? Yeah, no, I don't think so. So yeah, that's it. That's all I have for this one. Let me know what you think. Thanks for watching. Stay good, stay healthy to your mental health. I'll see y'all later and take care. Bye bye.